Okay, probability sampling. You might have learned about this, hopefully, in your statistics class. This is when you use random sampling techniques, and it allows a researcher to make a few observations and generalize that to the population. So what that means is we choose a sample. Let's say there's 1,000 youth that live in group homes in California. We're going to choose a sample. We're going to choose 100 of those. So those are a few observations, and then we're going to say our results can be applied to those 1,000 people because we used random sampling. So remember, generalizing is when we apply the results from our sample to the population. Okay, so a biased sample is when those selected are not typical or representative of the population. And this can frequently happen in non-probability sampling. So the way we get around that is to use probability sampling. So it's probability sampling if all members of the population have an equal chance of being selected. So once again, all members of the population have an equal chance of being selected. And then if that happens, then you're more likely to get a representative sample. So your sample is similar to the population. It won't be biased, and then you can have confidence when you generalize. Okay? Okay, so here are some terms. Population, we talked about this in the other video. That's the larger group that we want to know something about. Okay? So the theoretical specified aggregation of study elements. And when we say elements in here, for our purposes, we mean people. So that's our 1,000 youth who live in group homes in California. That's our population. The sample are those that we selected for our study. Those will be the 100 that we selected for our study. Random selection again means that every person has an equal chance of being selected. The sampling unit are the people that are considered for selection, and the sampling frame is the list of people that we're going to choose our sample from. Okay, next slide. So we want to be non-bias, and so we have to be careful about non-response bias also. So just because we have a representative sample doesn't mean that everybody that chooses to participate will be representative. Okay, so let's say we choose 100 people and only 70 of them send us back our survey. Let's say we do an electronic online survey. 70 send the survey back, 30 don't. So we need to look at those 30 people and their characteristics, and we need to find out if there's something important that's different about those 30 people who didn't respond. Because if there is, then we'll have non-response bias. If there's not, then we can go ahead and generalize. We also want to make sure that the proportion of people that don't respond isn't so large that it changes our results. Okay. Okay, so you learned about probability theory in statistics. This enables us to make estimates about the population and how likely it is to be accurate. There's always a margin of error. So plus or minus 3% is common in political polls. In statistics, we usually use plus or minus 5%. So now that we're coming up on a political season here in the fall, start watching the news, and when they tell you about a poll who's running ahead, look at the point difference and then look at the margin of error. How many points are they telling you? So if it's a 3-point margin of error and there's 3 points difference between the two of them, then they're really a statistical tie. Okay, so in order for someone to be ahead or behind, in reality, statistically, has to be about 6 points to actually make it a difference. Okay, so sampling error. So in statistics, if you remember, the p-value equals 0.05, so that's a 5% margin of error that we usually go with. Alright, there's a sampling error. This is the difference between the true population parameter and what our estimates are. So as our sample increases, the likelihood of random error decreases. So that's why we want to have a sample size that's large enough to say the likelihood of our random error is decreased. Another way to reduce sampling error is to have a homogeneous sample. However, the characteristics of your study may not allow for that. There is a statistic called power analysis. We're not going to talk, we're not really going to talk about it, but I just want you to be aware of it. It's a statistical analysis that tells you how big your sample should be so that you can generalize and reduce error. But we aren't going to, we're not going to go into that. This isn't a statistics class. Okay, types of probability sampling design. The most common is simple random sampling. So every person is assigned a number. So let's say I take my list of 1,000 youth that live in group homes in California, and I give everyone a number, 1 through 1,000. Then I use a random table or a computer, or I put all their names in a hat or their numbers in a hat, and I randomly choose 100 of them. This can be labor intensive if you don't have the computer to randomly choose. The next kind is called systemic sampling, and this is where you take your list and then you randomly choose a starting point, and that's the first person you choose, and then you choose every kth element. So for our study, let's say we have 1,000 and I randomly choose to start at number 22, and then I'm going to choose every 100 people. So I'd count to 100, and 122 is going to be the person I choose next. And then I count to 100. And 222 is the person I choose next. And you keep on doing that until you've got your 100 people. The third kind is called stratified sampling. This is used to obtain a degree of representativeness when there's certain characteristics that are important. And this is similar to something that's done in non-probability that we just talked about. So we organize our population into homogeneous groups. So let's say, my example for my dissertation, let's say we organize our population into age groups. So we have infants, preschoolers, school age, and high school age, or elementary school and high school age. And we say, okay, in the foster kids, what percentage are infants, what percentage are elementary or preschool, what percentage are elementary, what percentage are high school, and then we'll draw that number from each of those groups. That way, we make sure that we have the right proportion of all the characteristics that we're interested in. And then the fourth one is called multistage cluster sampling. And this is used when it's impossible to create a list of the entire population. This is how the federal government came up with the sample for the study I used for my dissertation. It's absolutely impossible to come up with a list of all the foster kids across the entire country. So what they did was they made a list of the counties, which is still quite extensive. It's a very large list. They made a list of all these counties across the country, and they selected 90, randomly selected 90 counties from there. Then they were able to call these counties and get a list of all the kids in each of these counties. So then they had, tens of thousands of kids in this list, and from there they chose 5,000 children. So this is still considered a random sampling design, but it's a little less accurate than the other ones. But it is used when your population list is so large it's impossible to get a list, and you still want it to be representative of the whole population. So it's a two-step process. We come up with a way to narrow the list down, and then we select from a narrowed list. Okay, so this week I'm going to ask you to come up with some sampling designs for your proposed study in your group. So I want you to look at these different ways of sampling and say, which ones of these are going to work for our study? And you'll need a sample for your quantitative study, and you'll need a sample for your qualitative study. You can use the same technique or you can use a different technique. It's up to your group.